October 1966, Detroit, Michigan. The air inside Ford's engineering building was tense, papers scattered across desks, cigarette smoke hanging thick. Somewhere in the distance, a V8 screamed on a dyno, loud, raw, angry. But it wasn't a Ford engine, it was Chevrolet's. And what it was doing made Ford nervous, because buried inside a small, lightweight Camaro was an engine that most people didn't understand yet. It didn't look intimidating. It wasn't massive like a big block. It didn't boast insane displacement. But what almost nobody knew is this engine was about to change everything. This was the story of the Chevy 302 Z28, the small block that forced Ford to rethink everything they thought they knew about performance. And trust me, you think you know this engine? Not like this. By the mid-1960s, American muscle was all about one thing: cubic inches. Bigger meant faster. Bigger meant stronger. Bigger meant unbeatable. Engines like Ford's 427 FE and Chrysler's 426 Hemi dominated headlines. These monsters pushed out over 425 horsepower and mountains of torque. They ruled drag strips and terrified street tires. The formula was simple. More displacement equals more air and fuel. More air and fuel equals bigger explosions. Bigger explosions equal more power. It was beautiful in its brutality. Walk into any performance shop in 1965, and the question wasn't whether to go big. It was how big you could afford to go. Pontiac stuffed 421 cubic inches into the GTO. Oldsmobile dropped in 442s. Ford was shoving 428s into Mustangs, and everyone thought that's how it would always be. They were wrong, but road racing? That was a different game. In 1966, the SCCA Trans-Am Series introduced a strict rule. Engines had to be under 5.0 liters. That's 305 cubic inches. Suddenly, all those massive big blocks were useless. The rulebook didn't care about your street cred. It didn't care about your quarter-mile times. It cared about one number: 305 cubic inches maximum. And just like that, the entire muscle car hierarchy meant nothing on road courses. Ford had been dominating with their Mustangs in SCCA racing. Their 289 high-performance engine was a proven winner. Light, reliable, and quick enough to handle the tight corners and elevation changes that killed heavier cars. They thought they had it locked down, but Chevrolet, they were watching. And Chevrolet saw an opportunity. Instead of going bigger, they went smarter. They took their proven small block V8 platform and created something entirely new, something surgical, something precise. They built a 302 cubic inch engine. But here's where it gets interesting. Instead of designing it from scratch, they created a hybrid. They took a 4.0-inch bore block from the 327 and paired it with a short 3.0-inch stroke crankshaft from the 283. Do the math and you get 302 cubic inches. But that combination wasn't random. That short stroke meant one thing: RPM. Lots of it. See, engine speed isn't just about how fast you spin the crankshaft. It's about physics. A shorter stroke means the pistons don't have to travel as far up and down. Less distance means less time per cycle. Less time per cycle means you can complete more cycles per minute. It's elegant, really. And it meant this engine could do something most American V8s couldn't. It could breathe at high RPM. While most V8s of the time struggled past 5,500 RPM, this engine was designed to scream past 7,000. Traditional American V8s would start gasping for air around 5,500 RPM. The valve train would float. The intake manifold couldn't flow enough air. The whole system would just choke. But a short stroke over square design, that changed the equation. Higher bore-to-stroke ratio meant better combustion chamber geometry, better flame propagation, more efficient breathing. And when you paired that with the right components, everything changed. At first glance, the numbers didn't seem revolutionary. The factory-rated output was 290 horsepower at 5,800 RPM and about 290 lb-ft of torque. Sounds modest, right? Ford engineers probably saw those numbers and relaxed a little. 290 horses? That wasn't scary. The Hypo 289 made 271. The new 302 Windsor would make similar power. Nothing to panic about. That's exactly what Chevy wanted you to think. Because in reality, that number was a lie, a deliberate one. With its solid lifter camshaft, 11.01 compression ratio, high-flow cylinder heads, and a big Holley 780 CFM 4-barrel carburetor, the real output was much higher. In race trim, these engines were pushing well over 350 horsepower. Some engineers quietly claimed it was closer to 375. And unlike big blocks, this power came alive at high RPM. You didn't just press the gas, you chased the red line. The power curve was different too. A big block would hit you with a wall of torque down low, instant grunt, tire smoking thrust from 2,000 RPM, but the 302, it made you work for it. Below 4,000 RPM, it felt almost tame, civilized even, but past 5,000, that's when it woke up. That's when the intake started howling, when the exhaust note turned from a burble to a scream, when the tachometer needle swept toward redline and the whole car felt like it was tightening, sharpening, coming alive. Drivers who were used to big blocks didn't understand it at first. They'd shift at 5,500 like they always did, and they'd leave half the power on the table. But the guys who learned to keep it singing between 5,500 and 7,000 RPM, they were untouchable. But there was a problem. Early testing revealed something ugly. At sustained high RPM, oil pressure dropped fast. The crankshaft bearings, those critical components spinning thousands of times per minute, weren't getting enough lubrication. And when that happened, they didn't just wear out. They failed catastrophically. Metal shavings filled the oil pan, bearings overheated, cranks seized. One test engineer reportedly said, "It sounded like the engine was eating itself alive." They'd run an engine hard for 20 minutes on the dyno, and when they tore it down afterward, the bearings looked like someone had taken sandpaper to them. Bronze material from the bearings would be embedded in the crankshaft journals. The oil would come out looking like metallic soup. This wasn't a minor issue. This was a catastrophic engineering flaw that could kill the entire program. Because here's the thing about road racing. Engines run at sustained high RPM for extended periods. Not just a quarter-mile blast, not just a few seconds of wide-open throttle. Minutes, lap after lap, corner after corner. And if your engine couldn't survive that, you couldn't race. So what do you do when your high-revving masterpiece is destroying itself? You fix the oiling system. Chevy engineers went back to the drawing board. They didn't panic. They didn't scrap the project. They got to work. Chevy engineers redesigned the oil flow path, improving pressure to the main bearings. They added high-capacity oil pumps and refined clearances throughout the engine. They changed oil passage sizes. They modified the windage tray to prevent oil starvation during hard cornering. They tested different bearing materials. They ran dyno test after dyno test, pushing engines to failure, analyzing what broke, fixing it, and trying again. It wasn't glamorous, but it worked. And what they discovered next changed everything. With reliability under control, the 302 came alive. Installed in the Camaro Z28, an option package quietly introduced in 1967, this engine transformed the car into a road racing weapon. Lightweight, balanced, responsive, and brutally fast when pushed hard. The Z28 package wasn't just an engine swap. It was a complete performance transformation, special suspension with stiffer springs and shocks, front disc brakes for better stopping power, quick ratio steering, a Muncie 4-speed transmission built to handle abuse, a 3.7-3.1 rear axle ratio that kept the engine in its power band. Everything was designed to work together. The result was a car that weighed less than 3,400 pounds with over 350 real horsepower and handling that could embarrass European sports cars. But Chevrolet didn't market it heavily. In fact, the Z28 was almost hidden. You couldn't just walk into a dealership and see one on the showroom floor. Most salespeople didn't even know what it was. You had to know to ask for RPO Z28. You had to be in the know. It wasn't advertised on TV. There were no big magazine spreads at first. No celebrity endorsements. Chevy built it for one reason: to meet SCCA homologation requirements. To race in Trans Am, you needed to build at least 1,000 street versions. In 1967, only 602 units were produced. They didn't even hit the minimum that first year. Most people had no idea what it was, but on the track, it was a different story. Enter the Trans-Am Series. This was where the 302 proved its worth. In 1968, Chevrolet partnered with Roger Penske and driver Mark Donohue. Together, they refined the Z28 into a precision racing machine. Roger Penske wasn't just a team owner, he was an engineer at heart, a perfectionist who obsessed over details that other teams ignored. And Mark Donohue, he was the same way. Driver and engineer in one, he could feel what the car needed, then help design the solution. Together, they were unstoppable. The engine received upgrades, improved intake manifolds, better exhaust flow, and race-tuned ignition systems. They tested different carburetor jetting for every track. They modified cam timing to optimize power delivery for specific circuits. They lightened every component they could without sacrificing reliability. Power climbed even higher. In full race specification, these engines were producing over 400 horsepower. Think about that for a second. 400 horsepower from 302 cubic inches in 1968. Ford's race-prepped 302 was making maybe 340. The Chevy had a 60 horsepower advantage. That's enormous. These cars weren't just fast, they were consistent, lap after lap, corner after corner. While bigger engines struggled with weight and heat, the 302 thrived in the chaos of road racing. At tracks like Laguna Seca and Sebring, the Camaro began to dominate. Other teams would watch in frustration as the Penske Camaro pulled away on the straights and carved through corners like it was on rails. The engine barely broke a sweat. Oil temps stayed stable. Coolant temps stayed in the green. And lap times just kept dropping. And Ford noticed. Because Ford wasn't unprepared. They had the Mustang. They had the 289 and later the 302 Windsor. But their approach was different. More torque. Less focus on high-revving precision. Their 302 was designed for street performance. Good low-end grunt, reliable, easy to drive, perfect for most customers. But on a road course against a purpose-built racing engine, and suddenly, that wasn't enough. The Camaro Z28, with its screaming 302, started winning. In 1968, the battle intensified. Mustang versus Camaro, Ford versus Chevy, Blue Oval versus Bowtie. Every race became a war. By 1969, it reached its peak. Mark Donohue drove the Penske Camaro to the Trans-Am Championship, winning 7 out of 12 races. 7. Not close wins either. Dominant performances, pole positions, fastest laps, leading from start to finish. That wasn't luck, that was dominance. And under the hood of that championship-winning car, a 302 that could rev past 7,500 RPM, producing over 400 horsepower in race spec. Think about that, 400 horsepower from just 302 cubic inches in 1969. That's over 1.3 horsepower per cubic inch, at a time when most engines struggled to hit one. Some of the Italian exotics could do it, sure, Ferrari, Lamborghini, but an American pushrod V8? That wasn't supposed to be possible. And Ford, they were in trouble. Inside Ford's engineering teams, the pressure was building. Meetings got tense. Executives demanded answers. Why were they losing? What was Chevy doing differently? The engineers knew. It was the oiling system, the valve train, the breathing. Chevy had simply out-engineered them. They had to respond. They refined their own 302. They improved airflow, cam profiles, and high RPM durability. They brought in the Boss 302 for 1969, and it was good, really good. But the truth was, Chevy had already changed the game. This wasn't about brute force anymore. It was about efficiency, breathing, RPM, precision. The small block war had begun, and the rules were rewritten. But even legends have limits. By the early 1970s, everything started to change. Emissions regulations tightened. The Clean Air Act hit hard. Compression ratios dropped from 11.0.1 to below 9.01. Horsepower numbers plummeted. Suddenly, engineers weren't designing for maximum power. They were designing for minimum emissions, smog pumps, EGR valves, catalytic converters. Every addition strangled performance a little more. Insurance companies began targeting high-performance cars, making them expensive to own. A young guy trying to insure a Z28 in 1971, the premium could cost more than the car payment, and the golden era of muscle started to fade. The Z28's 302 engine was discontinued after 1969, just as it reached its peak, just when it had proven what it could do. It was replaced by the LT1 350, which made more torque but couldn't rev like the 302. The soul was different, still fast, but not the same. Total production remained relatively low, making original Z28 Camaros rare and highly sought after today, but its impact, that didn't disappear. Because the 302 Z28 proved something that reshaped performance engineering. It showed that you don't need massive displacement to dominate. You need balance, airflow, RPM, and a design that can survive the punishment. It proved that American engineers could build high-revving engines that rivaled anything coming out of Europe. That pushrod V8s weren't just torque monsters. They could be precise instruments. It forced Ford to adapt. It pushed competition to evolve. The Boss 302 wouldn't exist without the Z28 302. Neither would the AAR CUDA or the Trans-Am Firebird. The entire pony car performance war escalated because of this engine, and it laid the foundation for modern high-revving performance engines. Today, engines revving to 8,000 RPM? That's normal. Back then, that was insanity. Engineers in the 60s thought American V8s couldn't do that reliably. The 302 proved them wrong. So what made the Chevy 302 Z28 so special? It wasn't just the numbers, it wasn't just the wins, it was the idea. Take a small engine, push it to its absolute limit, and make it survive. Build it light, make it breathe, let it scream, and prove that cubic inches aren't everything. That's what made Ford panic. Because once that idea worked, there was no going back. The genie was out of the bottle. Performance engineering would never be the same. If you enjoyed this story, let me know in the comments what you want to see next. Another rivalry, another forgotten engine, or another moment that changed automotive history forever. And don't forget to subscribe, because the next story, it might be even crazier.